Let's talk about hashing. Suppose we have a dataset, simply a bunch of numbers, and we want to find out if a value exists within that dataset. So in this example, we're going to be looking for the number 7. And this all may seem a little bit silly at first because we can clearly point it out with our eyes, but if we want a computer to do this for us, we need to store this data and then look for that value within that storage, since, computers don't have eyes. So let's transfer this data into a sort of list format. This list is called an array. Let's say we're still looking to find out if 7 is in the dataset. You need to look sequentially at each piece of data within the array until you find 7 to find out if 7 is actually there. Unfortunately, this method is kind of inefficient because, for one, you have to sift through a lot of unsorted data, but in the end, you would end up looking at each element in the dataset if you were looking for a value that didn't exist. So how can we be more efficient? Before we can figure that out, let's go off on a short tangent. What is modulo? Let's do a quick flashback to the 3rd grade, when things were simple and you were still learning how to divide. Instead of converting your answer to a fraction, you would simply write out the remainder. So if you had 13 divided by 3, you would get 4r1. In essence, modulo gives you that remainder. So 13 mod 3 would be 1. Here are a few example problems with mod, if you would like to pause and take a look at it. So now that we know what mod is, why does it matter? If we take a look at mod 3, we can see that the only values we can get are values from 0 to 2, which ultimately helps us do hashing. Let's go back to the array we had before. Now, instead of having a ginormous array, we have an array of fixed length with buckets. Let's say the length of the array is 7, so we have 7 buckets numbered 0 through 6. Which, if we're following the same principles as before, anything mod 7 will give us the value from 0 to 6. Now, as we store each element, we mod it by the length of the bucket array, which is 7. So based on what the result of the mod operation is, we place that number in the bucket. Let's say we have 12 mod 7 and we get 5 as a result. We will put 12 in the 5th bucket. Now, if we look for whether 7 is in the dataset again, we do 7 mod 7, which is 0, and we only have to look in the 0th bucket for 7 rather than looking through the entire dataset. So now, rather than looking through the entire dataset, the most searching we would have to do would be the size of the biggest bucket, which in this case is 4, which isn't a bad deal at all when it comes to efficiency. You're probably wondering, why does all of this matter? How does this impact the world? Well, we want our computers to run quickly, obviously, and one of the best ways to do that is to have efficient algorithms. For example, when we run Google Maps, it runs an algorithm to find the fastest and shortest path from point A to point B. It likely uses a lot of mathematical techniques and different types of data structures to make the algorithm run faster. So in essence, hashing gives us a faster way to find values, and that is eventually helpful in other larger algorithms. I want to impact this field of computer science by doing research in algorithmic efficiency, and hopefully one day I could contribute to solving P versus NP. Thank you so much for watching!